Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. But inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term.
August 23, 2023. A day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious: lunar ice. This place is believed to be more abundant with this ice than what we found up north, and it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now, picture this. Future lunar settlers could tap into this water supply. It could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the moon the same way? Now, you might wonder what resources the moon might offer. We know about the ice, and it can be turned into water. But we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the moon does have something to offer: mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the moon as well. Which is why scientists are learning how to turn the moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They become quite adept at it. So yeah, perhaps we're going to establish a little brick factory on the moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis 2 is set to carry astronauts to lunar orbit in 2024, and during Artemis 3, which should take place in the mid-2020s, 2 astronauts will touch down near the moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned. Now look at this fancy granite kitchen countertop. This one can also be available on the moon. I mean, there's no production whatsoever as of now, but there's enough raw materials for the kitchen of your dreams. And by the way, granite on the moon can even prove this dark horse had plenty of water at some point. So it all started when scientists found this weird blob of heat on the far side of the moon. It's all because of a massive chunk of granite that's buried underground. Apparently, granite is pretty rare outside of Earth, so this is a big deal. According to the researchers, there's this old volcano on the moon that hasn't erupted in like 3.5 billion years. But it turns out it's still giving off some serious radiation. The scientists used a fancy new method with microwaves to measure the temperature below the moon's surface. They found this area that's about 31 miles across, where it's like 18 degrees warmer than the rest of the place. And it's right under a spot that collapsed and is full of silicon. It's not as thriving as Silicon Valley back on Earth, it's just a volcanic crater, but without all the lava spewing out. The scientists even compared it to those granite rocks you see in Yosemite, like El Capitan and Half Dome. You know, those giant rocks that look super majestic? Well, apparently, they're made of the same stuff. Researchers claim that granite is super common on Earth, but not anywhere else in our solar system. So this could change everything we know about other rocky planets. Right, now we know there's granite on the moon, but why is that important to us? So, you know how granite forms on Earth? It's all thanks to water and plate tectonics teaming up to create these huge blobs of melted rock beneath the surface. But guess what? The moon doesn't have any of that action going on, which makes granite super rare up there. But this discovery could give us some clues about what the moon was like back in the day when it had volcanic activity. Without water, making granite becomes a real challenge. But somehow, someway, they found granite on the moon. No water, no plate tectonics, but still, we got granite. So what does that mean? Did the moon have water in this one spot? Or was it just ridiculously hot? I guess we'll need to give a tad more time for the scientists to figure it out. The water on the moon is an issue, though. Duh. As of now, the moon is bigger than the Sahara Desert, but somehow 100 times drier. Astronomers have been debating for ages whether there's any water on this celestial neighbor of ours. But in 2020, NASA's SOFIA mission finally confirmed that there is indeed water on the sunlit part of the lunar surface. Turns out those grains of lunar dust have little molecules of H2O hanging out on them. Back in 1645, when people first started gazing at the moon, they were fascinated by these dark spots all over its surface. Dutch astronomer Michael van Lengren even made a map and called these spots Maria, which means seas in Latin. Sorry, Michael, they're just actually plains of basalt from ancient volcanic eruptions, but we still use the term Maria today. In 1892, an American astronomer named William Pickering discovered that the moon has practically no atmosphere. No clouds, no atmosphere, no chance for water to stick around. So scientists started thinking that the moon was as dry as a desert. But then, in the 1960s, a theoretical physicist named Kenneth Watson came along with an idea. He suggested that water ice could actually exist in the shadowy craters of the moon that never see sunlight. These areas are called permanently shadowed regions. It was a mind-blowing concept at the time. The Apollo missions from 1969 to 1972 finally gave us the chance to look for water on the moon up close and personal. But when the astronauts brought back soil samples, there was no sign of water. So everyone went back to thinking the moon was bone dry. However, in 1994, NASA's Clementine mission suggested that there might be ice in these shadowed craters after all. And in 1998, the Lunar Prospector mission found evidence of hydrogen concentrations in the permanently shadowed areas. This was a strong indication of water ice at the lunar poles. The images weren't super clear, but it was still an exciting discovery. And finally, in 2008, scientists decided to take another look at those Apollo samples. They revisited the old data and found some hints that there might be water after all. It was like finding buried treasure in your own backyard. As you can see, the moon is a pretty promising destination. It even has enough stuff to produce your food supplements – calcium, magnesium, you name it. Just kidding, it's not the best idea to munch on them to boost your diet. But there are a bunch of other applications they can be used for. Calcium is like the fourth most popular element hanging out in the lunar highlands. But here's the cool part. Pure calcium metal is actually super flexible and can conduct electricity like a boss when there's no oxygen around. Who knew, right? Anorthite is a rare gem here on Earth, but up on the moon, it's partly central for calcium. It can even help make those groovy silicon-based solar cells. To make them, you need some lunar silicon, iron, titanium oxide, and of course, our buddy calcium and aluminum. It's like a recipe for solar success up there in space. The moon even has precious metals like gold. In 2009, NASA was on a lunar mission and they found some gold in the lunar soil. They had a spacecraft right behind the rocket, equipped with a fancy spectrometer. Its job was to study all the debris that got released when the rocket crashed. And they found all sorts of chemicals, like carbon monoxide, carbon dioxide, ammonia, sodium, hydrogen, and even a little bit of mercury, gold, and silver. Hey, vampires beware. Now I know it's been quite a while since then, like 14 years to be exact, but measuring how much gold is actually there has been a real challenge. You see, it's hiding deep beneath the lunar regolith, making it tricky to get an accurate count. Yeah, metals are fun and lunar water may have existed, but what about food? Good news, everyone! Scientists are saying that plants can actually grow on the moon, but don't expect a luscious orchard. It'll be more like a moderate garden with just a couple of beds. Here's the scoop. A while back, those awesome Apollo astronauts collected samples of lunar surface material called regolith and brought them back to Earth. Fast forward 50 years, and NASA decided to use 3 of those samples to try growing plants for the very first time. They used dirt from under the lunar rover bumper to grow these plants. The team added water and seeds to the samples, giving each plant a gram of regolith. Then they placed them in a clean room and added nutrient solutions every day. And they succeeded. During that challenge, the brilliant minds dealt with small plants like mustard greens in the nutrient-poor lunar soil. Yeah, we'll have to export olive oil from Earth to dress it. So, plants can indeed grow in the moon's soil. However, they won't be as strong and healthy as the ones grown on good old Earth soil, or even the ones in the control group grown in a lunar simulant made of volcanic ash. But hey, it's just a start. We're still to find out if our dear moon is hiding more treasures. Have you ever seen the other side of the moon? I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the two sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit. And since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had two teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually two tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes, traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the moon, somewhere near the South Pole. This collision was so strong that it changed the image of the moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the moon. It caused damage to the moon's mantle. It also created a so-called South Pole Aitken Base, or SPA basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important though. The formation of this basin was a defining event in the history of the moon, and it's the second largest impact crater in the solar system. The collision also caused a powerful hot wave to spread across the moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscoviense. This is the name of a large lava plain on the far side of the moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the moon, but it's also handy for space exploration in general. Scientists use the moon as a reference point to determine the age of other planets and entire worlds in space. The moon helps us determine the chronology of the life of the whole solar system. So, stay tuned for new exciting research and discoveries.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the Moon is made up of layers, a crust, mantle, and core. However, the Moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The Moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the Moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the Moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the Moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the Moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the Moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the Moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the Moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the Moon's gravity as they go. It's like they were feeling the Moon's invisible pull in different places. If the Moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the Moon, even if they can't actually go there. And the spacecraft intentionally crashed into the Moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the Moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's $1 million questions. The Moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the Moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the Moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the Moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the Moon itself, it also tells us more about other celestial bodies. If the Moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the Moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the Moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty, hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
In 2024, Earth was joined by a mini-moon that orbited around our planet for 2 months. It hung around, made a few laps, and then, like every polite guest, it left. It went back to resume its trip around the Sun. However, astronomers now say another rock has been tagging along with Earth not for weeks, but for 6 decades. It's rare and strange, now being classified as a quasi-moon. But what exactly does that mean? Is it like a backup satellite? Unlike our cool and mysterious moon that illuminates our nights and affects werewolves, a quasi-moon doesn't circle Earth. Instead, it orbits the Sun, but it does so almost in perfect sync with us, like a runner doing a marathon with you that keeps a similar pace. Space only seems calm. It's actually pretty chaotic. The Sun, the Moon, Earth, and even other planets are constantly tugging on each other and smaller objects like these rocks. Most asteroids can't hold this delicate balance for long. They either get nudged into a new orbit, pulled closer to Earth, or flung out into the vast reaches of space. That's why we're lucky to spot more than 1 or 2 at a time. Most just can't keep the balance. They belong to a bigger family called co-orbitals. In fact, astronomers group them into a few types based on how they move relative to Earth. But unlike the real moon, that's been our companion since the very beginning, these visitors don't stick around forever. Some hang with us for a few decades, others for centuries, before drifting away because the gravity of some other space object. Kinda like a dog running to your neighbor after smelling bacon. One other thing about quasi-moons is their size. Most are tiny, building-sized or even smaller. They're also so dim that they can hide in plain sight among stars. Still, they're important. By studying them, astronomers learn how small near-Earth objects move and how long they can stay caught in Earth's gravity. Quasi-moons are closer than other asteroids on the same path, and it would be easier to reach them. One day, they might be used as stepping stones in space exploration. Earth has had a few of these tag-alongs before. One of the most famous is 2016 HO3, nicknamed Earth's Constant Companion. It's only about 300 feet wide, but it's been keeping pace with us for nearly a century. Researchers say it might keep up for centuries more. But what about the most recently discovered one? The researchers named it 2025 PN7. Like we said, it's already been with us for 60 years and will likely stay for around 68 more. For a long time, it remained undiscovered because of its tiny size, only about 62 feet across, which is about the length of a bowling lane. This also answers the question of whether you could see it yourself if you knew where to look. Its backstory is a bit of a mystery. Astronomers haven't figured out its composition yet. Right now, all we know for sure is its trajectory. Some quasi-moons are just near-Earth asteroids that fell into a perfect orbit. Others seem like they could be chunks of the moon itself. For instance, there's another quasi-moon named Kamo'olaloa that reflects light in almost the same way as the lunar rocks we brought back during the Apollo missions. Because of that, some researchers think it might actually be leftover from a huge impact that happened long ago. There's also 2024 PT5, a temporary mini-moon from the end of last year. Tests showed that its surface looks like lunar basalt, suggesting it probably came from the moon. So how do these quasi-moons pull off their cosmic balancing act? That's because it's just an orbital illusion. Remember, PN7, like other quasi-moons, isn't actually circling our planet. To us, it looks like the rock is scribbling lazy loops around Earth's path, like doodles in space. Yet it never lags too much or gets too far. Astronomers call this a one-to-one resonance. In plain English, it makes a lap around the Sun every time Earth does. Another fun question. If these fake moons are so close to Earth, why don't we just pull them in with our gravity? Especially since they're tiny and seem so near. That's because even though they belong to a group called near-Earth objects, quasi-moons are not that close. Our moon is hanging out about 239,000 miles away. These companions, though, are flying around the Sun millions of miles out, way beyond Earth's gravitational pull. That pull exists within an area called the Hill sphere, which is where Earth's gravity is stronger than the Sun's. Think of Earth's gravity as a bubble with a radius of about 1,000,000 miles. Anything inside can get caught, like the real moon. Step outside, and the Sun takes over. This is exactly what happened to PT5, which was our legit satellite for 2 months in 2024. It dipped inside the Hill sphere, and Earth's gravity took over. Once it happened, this object became known as a mini-moon. But because it was small and moving fast, it eventually slipped back out of that bubble, and the Sun's gravity pulled it away again. One other type of co-orbiter, aside from quasi-moons and mini-moons, is the so-called horseshoe orbiters. These space rocks don't stray far, but from Earth's point of view, they seem to swing ahead of us, slow down, then drift back behind, and repeat. It's like an undercover cop tailing you in traffic, but constantly switching lanes and doubling back so you don't notice the pattern. If you trace their motion from Earth, over time, it forms a giant horseshoe shape, hence the name. And these are just the main co-orbiters. There are actually more. Way ahead of us and way behind us in space, there are a few quirky rocks called Trojans. They're not just following right next to Earth like quasi-moons do. Instead, they found 2 special hiding spots. One 60 degrees in front of us and one 60 degrees behind. Imagine riding your bike and having a friend way ahead of you and another one way behind. both keeping the same speed. That's what Trojans do. Those spots are called Lagrange points, cozy hangout regions where the gravitational pulls from Earth and the Sun balance out perfectly. When they find themselves in one of those areas, they could be staying there for millions of years without drifting away. Jupiter, for example, has tons of these freeloaders. Earth has only a few. Then there are tadpole orbiters. Instead of sitting perfectly still in a Lagrange point, they wobble around it in lazy bean-shaped loops. And if that's not confusing and overwhelming enough, there are also jumping Trojans, the indecisive ones. These guys can't pick a side. They'll spend a few thousand years staying in the front hammock, then slowly drift to one behind us and back again. Rare, weird, and kind of awesome. So even though Earth only has one big moon in the sky, we've actually got a whole gang of intrusive space tag-alongs. Some loop, some trail, some hide in the corners. Now let's recap the superpowers of our moon. It can affect tides, slow down Earth's rotation, and even help stabilize our planet's tilt. Without the moon, our days would be shorter, our nights darker, and the seasons way more chaotic. The moon also acts like a giant shield, sweeping up or deflecting some space rocks that might otherwise smack into Earth. And let's not forget its cultural influence. It's been inspiring myths, calendars, love songs, and millions of melancholic walks in the middle of the night. Fake moons can't compete. However, they are important in their own way. Each new quasi-moon we find helps us understand how these little rocks survive in all that cosmic chaos. By learning about our environment, we also learn something about ourselves. They sharpen our detection skills and help us improve our models. So while they'll never shine in the night sky, they still play a quiet role in helping us understand our quirky cosmic neighborhood.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions, but they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there, and launch them way easier in space. It could also help us in another important project. Figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000, from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must, That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
Way out by Saturn, there's an icy moon called Enceladus. And it's literally spitting out ice into space. And that ice contains the stuff life's made of. Oh, and there's a whole ocean hiding under the ice. And who knows what's living in it. Enceladus is only about 300 miles across. It could literally fit inside the state of Colorado. But even though it's super small, it's got liquid water, energy from hydrothermal vents, and a bunch of chemicals that could actually support life. In other words, it's one of the best spots in the solar system where life could exist. Now, rewind about 20 years. NASA's Cassini spacecraft flew by Saturn and noticed something strange. Enceladus was shooting out little jets of icy particles from cracks near its south pole. Later, scientists realized those jets were coming from a giant underground ocean beneath the moon's surface. When they analyzed the frozen grains from those plumes, they found almost all the elements needed for life: carbon, hydrogen, nitrogen, oxygen, and phosphorus. Only sulfur was missing. The only problem was, most of those samples came from Saturn's E ring, a huge ring made of dust and ice that surrounds the planet. And those particles had been sitting out there for decades, maybe centuries, meaning they could have been changed by space radiation. So no one could say for sure if those life ingredients really came from Enceladus itself. But now that's changed. A new study has just confirmed that fresh ice grains, the ones newly blasted out from Enceladus, contain organic molecules, including stuff like nitrogen and oxygen. Here's how scientists figured it out. In 2008, Cassini flew right through one of those icy geysers, and it literally got splattered with tiny particles. They hit the spacecraft's dust detector at insane speed, 11 miles per second. That's fast enough to separate all the molecules, so the team could see what they were really made of. Then the scientists used a technique called mass spectrometry and managed to study those fresh grains in detail. They found molecules that on Earth are part of certain chemical reactions. Those build the complex structures life needs to exist, including ones that may contain nitrogen and oxygen.
One of the researchers said that this likely proved that those complex organic molecules hadn't formed in space. They might have actually been coming straight from Enceladus's ocean. Another scientist explained that those molecules could play an important role in biological processes. All this means that Enceladus might really be habitable. But even if there's no life there, that's still a big deal. Because then we have the right to ask, wait, why isn't there life when all the right conditions are in place? The story doesn't end there. The European Space Agency is already planning a future mission to actually land on Enceladus, right at its south pole. They want to scoop up more samples and see what's really going on under all that ice. The launch is planned for sometime in the early 2040s, so in just a few decades, we might finally find out whether this tiny frozen moon is home to some bizarre life forms. But Enceladus isn't the only potentially habitable place we know about. Admittedly, the others are beyond the edge of our solar system. Like 3 possible super-Earth planets orbiting a nearby orange dwarf star. Now, super-Earth is just what scientists call planets that are bigger than Earth but smaller than the icy giants like Uranus and Neptune. Scientists from the University of Exeter found that those exoplanets were orbiting their parent star, HD 48498, which sits about 55 light-years away from Earth. That's practically our cosmic neighborhood. Each of these planets takes a different amount of time to go around its star. One needs 7 Earth days, another 38 days, and the last one 151 days. And the coolest thing is that the outermost planet might actually be hanging out in the star's habitable zone. That's the sweet spot where it's not too hot and not too cold for liquid water to exist. It means the planet's surface could be comfortable enough for water to exist without boiling or freezing. This makes it a great candidate for life as we know it. Over 10 years, the team collected nearly 190 super precise measurements using cutting-edge equipment that looks at the light coming from stars. By checking whether the star's light is slightly shifting toward us, this is called blue shift, or away from us, that's red shift, they can figure out if a planet is tugging on it. The host star itself is an orange dwarf, something like our Sun's smaller and calmer cousin. It's similar to the Sun in many ways, but as an orange dwarf, it gives off less radiation than our yellow dwarf star does. The coolest part is that this is one of the closest planetary systems we've ever found that hosts a super-Earth in the habitable zone around a Sun-like star. Now, super-Earths aren't exactly rare. Scientists have found over 6,000 exoplanets since the first one orbiting a Sun-like star was confirmed in 1995. To spot such distant worlds, astronomers use all sorts of tools, like NASA's Kepler telescope, launched in 2009 to find Earth-like planets in the Milky Way. Let's sneak a peek at some of the most exciting exoplanets out there. Gliese 667cc is only 22 light-years away, even though that's still about 129 trillion miles from us. It's about 3.8 times the mass of Earth, and zips around its red dwarf star in just 28 days. So a year there is 13 times shorter than ours. Its red dwarf star is cooler, and the planet probably sits in the habitable zone, though occasional stellar flares could give it a sunburn. Kepler 22b is way farther out at 600+ light-years. It was the first Kepler planet found in a habitable zone. It's about 2.4 times bigger than Earth, and we still don't know if it's rocky, liquid, or gaseous. Its orbit is close to Earth's, taking 290 days to circle its G-class star, smaller and colder than our Sun. Kepler 69c is a whopping 2,700 light-years away. This planet is almost 70% larger than Earth. Its orbit takes 242 days, putting it in a Venus-like spot in its system. But since its star is only 80% as luminous as our Sun, the conditions on that planet might be way friendlier than those on Venus. We discovered TOI 733b in 2023. This world is about 245 light-years away. It orbits its star super fast, taking just 4.9 Earth days. But the coolest thing is that it might be completely covered by a massive ocean. Could there be life in that ocean? Time will tell. GJ 1214b is 40 light-years away, pretty close by space terms. The planet is almost 3 times Earth's diameter and 8 times as heavy. It needs 38 hours to orbit its red dwarf star. The surface temperatures there hit 450 degrees Fahrenheit, and with all that heat and pressure, water behaves in crazy ways, like hot ice or superfluid water. By the way, that superfluidity is wild stuff when water moves like magic without friction. But don't try it on Earth. You'll just get dehydrated. Proxima Centauri b is the closest super-Earth, sitting at just 4 light-years away. It has a similar mass to Earth's, but a year there is only 11.2 days. Its star even wobbles a bit thanks to the planet's gravity. That's actually how scientists discovered it. The planet sits in the habitable zone but gets blasted by extreme UV radiation because it's super close to its star. Right now we can't even study its atmosphere. And finally, TOI 715b. This one orbits a red dwarf, which is smaller and cooler than our Sun. These tiny stars are pretty great for finding habitable worlds because planets can orbit close without frying. TOI 715b may have once had a super thick atmosphere like Neptune's, but it might now be losing it. Scientists need more research to see if it's now a watery, rocky world. In any case, some of these planets might have oceans, some might be way too hot, and some could even be our distant cosmic cousins. Either way, each discovery helps us understand the universe a little better. And who knows, maybe someday we'll even set foot on one of those super Earths.
We just found the biggest clue ever that someone lived on Mars. Or should I say, something. Because if you're picturing skinny red extraterrestrials with big goofy eyes, forget it. The Martians we're talking about looked more like this, a tiny microbe. I know, a total bummer, but this could change everything. See that weird pattern on the rock? The one that looks like leopard spots? Experts think it was left behind by ancient life. And no, it's not like someone painted it, the way early humans drew on cave walls. These little marks could actually be leftovers from microbes. Signs that some pretty wild chemical reactions were happening back when they were formed. And don't worry, we'll get to that in just a second. So NASA actually found this evidence over a year ago, and they were thrilled, as this was exactly the kind of weird rock they'd been hoping to see on Mars. They thought this weird pattern might be a biosignature. In other words, a clue that life was once there. That could mean an element, a molecule, some substance, or in this case, a funky leopard print pattern on a rock. But scientists were cautious back then. After all, you can't just go around shouting, "We found life on Mars," without being absolutely sure. It could have just been, well, a cool-looking Martian rock, right? So, they studied this sample again and again. And by they, I mean more than 1,000 scientists from NASA and partner institutions all over the world. And recently, they finally came out with a paper that basically says, listen, we can't find another explanation. And that's it. With no other explanation left, this might just be the best evidence we've ever had that something really did live on Mars. The sample, nicknamed Sapphire Canyon, was collected by the Perseverance rover in July 2024. It was taken from rocky cliffs along the edges of the Neretva Vallis River Valley, a region shaped long ago by water that once flowed into Jezero Crater. And we're talking like more than 3 billion years ago. Scientists believe that back then, Neretva Vallis was filled with rushing rivers carrying mud, sand, and gravel into the lake. When the water eventually dried up, it left behind the rocky outcrop where Sapphire Canyon was found. After collecting the sample, the Perseverance rover kept exploring the river valley to get a better idea of the environment where those rocks formed, and to figure out how those leopard spots might have appeared. That step matters because knowing exactly how the spots came to be is key to figuring out if the rock really holds signs of life. In other words, did those patterns form through normal chemical processes that don't need life at all? Or were they actually left behind by microbes? What the rover's instruments found is that the rocks in this area are made of clay and silt, which is exciting. because here on Earth, those materials are great at preserving signs of ancient microbial life. The rocks are also packed with organic carbon, sulfur, oxidized iron, and phosphorus. And you know who loves that stuff? Microbes. Experts think they could have used those ingredients as an energy source, and in the process, left behind the leopard spots we can now see in high-resolution images. Remember when I said these marks might be a microbe's leftovers, right? That's exactly it. Picture you're eating a burger called the Galaxy Burger that has a one-of-a-kind sauce. A drop of that sauce falls on the table. You don't clean it up, and a second later, poof, you disappear. Later, detectives show up trying to figure out if you were there. All they find is that sauce drop you left over. From that, they can tell exactly what you were eating: the Galaxy Burger. But proving you were really there is tricky, since that sauce could have ended up there in lots of other ways. The same goes for the leopard spots. Just by looking at them, scientists can already tell a few things. For example, the pattern shows the presence of two iron-rich minerals, vivianite and greigite. On Earth, vivianite often turns up in sediments near decaying organic matter, or in swampy, soggy wetlands. In a similar way, microbes can also produce greigite on our planet. When you find those two together, it looks like they formed through electron transfer reactions between the sediment and organic matter. That could be a fingerprint of microbial life, because microbes use those reactions to get energy and grow. So, going back to our burger comparison, the leopard spots are like the sauce on the table, the leftovers from the process of getting energy. But that's not the only theory. The team also spotted the possible presence of hematite in the rock. And if Mars has the nickname the Red Planet, hematite is the one to blame. It's a heavy mineral that can take on a reddish tone. On Earth, people have been using it as a pigment for paint for thousands of years. Now, scientists think the leopard spots may have formed when chemical reactions with hematite turned parts of the rock from red to white. That process can release iron and phosphate and possibly cause those black rings to appear. And here's the kicker. Those reactions can also provide an energy source for microbes. For now, though, these are just theories. What we can confirm is that those chemical compounds are definitely present in the rocks. But just like in the detective story, finding the sauce drop doesn't prove it came from you. So even though these materials are great for microbes to thrive on, it doesn't automatically mean this is a biosignature. They could have also formed abiotically, or, put simply, without the presence of life. Yeah, it could happen, but for it to happen naturally, without microbes involved, you'd need two things: high temperatures and acidic conditions. That's the only way those chemical processes could do their magic and leave behind the leopard spots. And here's the exciting part. Scientists didn't find any sign that these Martian rocks were ever exposed to high heat or acidic conditions. That's why I said they're stumped. They just can't find another explanation. So this has to be a biosignature, right? Well, maybe not. Because there's still a possibility that organic compounds could react even under low temperatures. And maybe, just maybe, we're seeing that happening for the very first time. That's why it's so hard to confirm 100% whether this is the handiwork of ancient microbes or just a natural process. So, in the end, we're still left with more questions than answers. Right now, this precious sample is safely sealed inside a tube millions of miles away on Mars. Hopefully, one day, it'll be brought back to Earth so scientists can study it in labs here. And while we can't confirm it's a biosignature just yet, one thing is certain. This finding by Perseverance is the closest we've ever come to discovering life on Mars. Honestly, just being able to spot a potential biosignature on the Red Planet is already groundbreaking. Another reason this finding matters has to do with the age of the rock. This evidence comes from some of the youngest sedimentary rocks we've ever studied. Until now, Scientists thought that if we ever found signs of ancient life on Mars, they'd most likely be locked inside much older rocks. But so far, nothing has shown up in those ancient formations. Finding a possible biosignature in a young rock suggests two things. First, Mars might have been habitable for longer or later in its history than we ever thought. And second, older rocks might also hold signs of life, but maybe they're just harder to spot. Someday, our technology could be advanced enough to find them. This discovery also makes us think about one of the biggest questions of all, and that is, are we truly alone in the universe, or did we just find the answer? No, not exactly, but it's the closest humanity has ever come to answering that question.